Hello, I am Cooper Isaac, and this is my Neuron project. First, we have the axon, this long little strip right here. The point is to carry nerve impulses away from the cell body. Next, we have the dendrites. The point of dendrites is to convert these signals into small electrical impulses and send them inward. Right? Next, we have the soma, which provides energy for these activities to take place. Next, we have the terminal axon, located down here. This is communication through the neurotransmitters. That's what this provides. Next, we have the myelin sheath, which is this part right here, covers the axon. And the point of it is to allow electrical impulses to transmit quickly and efficiently along the nerve cells. Next, we have the neuron transmitters, which I believe are down here. Not always down here, they're more around the ball area. And the point of these is to transmit messages between neurons, or from neuron to muscle. Next, we have the synaptic gap, located right here, which kind of can be all over, but it's a little gap when receiving signals. The point of it is it's important for cells to communicate using chemical transmission. Next, we have the nucleus, located inside of the cell body right here, and it allows, or it holds the information which allows this to be made, holds the DNA. Next, we have the terminal sac located down here, which stores the neurotransmitters. Next, we have the nodes of Ranvier, and then here, these are little places in between the myelin sheaths. You can't really see them, but they're there. And they facilitate the rapid conduction of nerve impulses. Next, we have the receptor site down here, two of these. This contains receptor molecules that receive and react with particular messenger molecules. Next, and second to lastly, we have the presynapsis. Where's the presynapsis? It's down here. Right here. And what it does is it sends a signal towards a synapsis, and then with the postsynaptic synapsis neuron, just down here, and it receives the signal, receives the neurotransmitters. At the end of it, I'll try and give you a view of it without labels, a little bit cleaner, a little bit nicer, a little bit see more clearly what it looks like. Next, we have the action potential. Action potential has three main stages: depolarization, repolarization, and hyperpolarization. First in depolarization, you have the resting potential. This is when nothing is happening, right? No stimuli has been produced yet. Next, then when a charge passes the threshold, so like a successful charge, you have depolarization. This is the first step. Basically, if it's a graph, it goes up at this point. This is where the all or nothing principle applies, which states that the strength of the response of the nerve, cell, or muscle fiber is not dependent on the strength of the stimulus that it receives. Now, early in the process, one of the first steps was that neurotransmitters were released. But now at this point is when reuptake would take place, which basically the point is to recycle all those and put them back in the terminal sac. And after all that, the process enters a refractory period where basically, looking at the graph again, it goes up and it gets down below the resting point. So this is where nothing can happen, basically. And then it goes back up to the resting period and ends action potential.